Now we can see one of the experiment in power system laboratory 2 for ME power system engineering students of semester 2. This is experiment number 8, intelligent control techniques for automatic generation control. The aim of the experiment is to design automatic control loop of a power system and to improve the performance using any intelligent control technique. Here I have used a fuzzy logic controller. So automatic control loop, that is, this is automatic generation control system is nothing, you can call it as also automatic load frequency control system. So the software needed is MATLAB 2014 or updated version of this. The theory behind this is the ALFC loop shown. This is the theory behind this. So this is a ALFC loop. So it achieves the primary goal of real power balance by adjusting the turbine output to match the change. Yes, what you are doing, output, turbine output, that is adjusted to match the load in the change in the load demand. Okay, so the steam input is adjusted to match the change in the output load. Okay, so this is a governor, a turbine, a power system. So it forms a primary loop, secondary loop, and this is the system, control system diagram that is there. So in a single area system, there is no tie line schedule to be maintained. Thus the function of AGT is only to bring the frequency to the nominal value. This will be achieved using the supplementary loop, which uses the integral controller to change the reference power setting so as to change the speed set point. The integral control KI, see here, see this is a MATLAB simulation diagram. So that I have connected a governor, a turbine, and then a generator load combination. Then output as seen through by means of scope and a display unit. Then there is a fuzzy logic controller. Then there is a gain and then integrator. So there is an integrator output has been integrated and also given to a fuzzy logic controller. So fuzzy logic controller, you can use any falsification process. There is a rule based system, if and then rules you can define, and then you can control the output of the generator load combination. So this is the output response. So there are, here I have shown 4 number of curves. So the curve with green color, that is without controller. Then pink color shows with controller, with PI controller. Then at last one red color curve that shows the fuzzy logic controller. So in the fuzzy logic controller, the error is very, very less. So we can recommend this fuzzy logic controller to reduce the error for this LFC system. So LFC system, there is a governor system, there is a turbine system whose governor time constant TG, and then gain constant KG, similar turbine time constant KT, TT, and then gain constant KT. So all these values you need to define. You need to define all are predefined values. Okay, all are predefined values, so you need to define. Then that generator load combination, there are some variables, that is damping coefficient D, then inertia constant H. So these are also constant only, you need to define everything. So which is your control parameter? Your control parameter is output of the generator load combination, delta omega S. That is controlled by means of this fuzzy logic controller. Okay, so you need to be clear which one is your input for this fuzzy logic controller. Okay, then only you can define the fuzzy logic controller. This fuzzy logic controller, you can take this from the toolbox available in the MATLAB. So just you can give the input. Okay, it is a Mamdani system, so you can take that system and then you can just like that you can define the membership function, and you can incorporate the if-then rules, and at last you can connect the output to this Simulink diagram, and finally you can plot the graph like this. So at last result, thus the automatic control loop of the power system is designed and the performance is improved using fuzzy logic controller. Thank you.